Hi 301, today I will be going through titration, which is method 2 in salts preparation. This method is used to prepare sparse salts or sodium, potassium and ammonium salts. We have learned method 1 yesterday, where we can prepare a soluble salt by reacting an acid with metals, insoluble bases or insoluble carbonates. However, this method cannot be applied to sparse salts, as the final salt solution and the resulting salt crystals formed may not be pure. Remember that in method 1, we use an excess of the non-acid reactant to ensure that all the acid has reacted so that no traces of acid remain in the salt solution. We can then remove the insoluble reactant by filtration. Hence, the resulting salt solution and the salt crystals formed will be 100% pure. However, this is not the case for sparse salts. The reagents used in the preparation of sparse salts are all soluble. Hence, an exact proportion of each reactant must be used to ensure that there are no traces of either reactant in the final salt solution obtained. Hence, a titration must be performed to determine the exact volumes for each reactant used. It is important to use an indicator to determine the endpoint during titration, where complete neutralization has occurred. As such, it is important to remember the colors of the endpoint of titration for the common indicators that we use in the lab, such as methyl orange, screen methyl orange, and thymophthalin. The endpoint colors of these three indicators are orange, grey, and blue respectively. Here are some photographs to illustrate what the endpoint colors will look like for these indicators. So as we can see in the first photograph, the endpoint of methyl orange is orange, and the endpoint for screen methyl orange is grey in the second photograph, while for thymophthalin the endpoint color is blue in the last photograph. So now let us move on to the procedure for the preparation of a soluble salt using titration. This procedure involves two parts. Firstly, the titration to determine the volumes of reactants required, and lastly, the preparation of the pure dry sample of salt required. Let us look at this example for the preparation of a pure dry and white sample of sodium chloride using the soluble starting reactants of sodium hydroxide and hydrochloric acid. We first use a pipette to measure exactly 25.0 cm³ of dilute hydrochloric acid to transfer into a conical flask. Then we add few drops of an indicator, or thymophthalin in this example. The resulting solution is colorless as the solution is acidic. Next, we fill a burette with sodium hydroxide and note the initial burette reading. We will add sodium hydroxide drop by drop into the conical flask, and so each time each drop is added to ensure that the contents are mixed well. The indicator will change from colorless to blue once the endpoint of the titration is achieved, as there will be a drastic change in pH during complete neutralization, which causes the change in color. This can be seen in the pH graph that I drew on the top left corner of this sample procedure. As you can see, this drastic change in pH will cause the color change for the indicator that we use in titration. We will now obtain the final burette reading, and the volume of sodium hydroxide used can be calculated by subtracting the initial reading from the final reading. We will repeat this procedure to obtain another set of readings, and where two sets of readings only deviate each other with a plus minus of 0.20 cm³. The average of these two readings will be taken. So now that we have determined the exact volume of sodium hydroxide that is required, we will repeat this procedure without the use of an indicator this time. So similarly, we will add this exact volume of sodium hydroxide to 25.0 cm³ of hydrochloric acid. Now, without the use of an indicator, this will ensure that the resulting salt solution that we obtain at the end has a neutral pH and is 100% pure without any trace of impurities from either acid, base, or indicator. The next few steps are the same as the last few steps of method 1 that we have learned yesterday, from steps 9 to 13. As the both of the rationale for the steps 9 to 13, the rationale is to obtain a salt crystals from a soluble salt solution. So similarly, we will transfer this solution into an evaporating dish to be heated until a saturated solution is formed. It is then cooled so crystals can be formed. These crystals are then filtered and washed with a little cold distilled water to remove any impurities. Do note that a little cold distilled water is used only because if you use too much cold distilled water, these soluble crystals will actually dissolve in this water. So lastly, the last step is that we will press these crystals dry between sheets of filter paper to obtain a pure dry sample of sodium chloride. This procedure is a standardized procedure which you must be familiar with for the preparation of spa salts. Please spend some time to consolidate what we have learned today. The last salt preparation method of precipitation, which is used to prepare an insoluble salt, will be introduced as the final salt preparation method for this chapter. We will do a final recap and consolidation of all 3 salt preparation methods at the end of this chapter. Thank you.